We're going to talk about molarity, not two of the Three Stooges. Molarity is a term we use in chemistry to discuss concentration of solutions. Okay? So first we want to understand that a solution generally has two parts. We have what's called the solute. The solute is the part of the solution that dissolves. Most of the solutions we're going to be working with are aqueous, and in an aqueous solution, the solute is the stuff that's dissolved in the water. Sodium chloride or some usually ionic compound or some soluble molecular compounds. Okay? The other part is called the solvent, and that's the part that does the dissolving. In the case of an aqueous solution, the solvent is water. Okay? So solute, solvent. And when we talk about concentration or molarity, what we mean is the ratio. And it's a specific ratio. You notice in the word molarity, you hear the word moles, right? Or mole. Molarity is the ratio of moles of solute, how many moles of solute you have dissolved, over the total volume of solution, okay, in liters. The units of molarity are moles per liter then. Or we sometimes just use a capital M and it's usually underlined. That capital M you've seen before. For example, 6M HCl, the M is molar. That means there are 6 moles of HCl per liter of solution. Okay? So molarity is the number of moles of solute divided by the number of liters of solution. Here's an example. We're going to make a solution. We're going to dissolve 15.00 grams of sodium chloride into 750 milliliters of water, and we want to calculate the molarity of that solution. Okay? So remember, molarity is moles of solute over liters of solution. Okay, so the first thing we need to do is to figure out how many moles of solute we have. Well, sodium chloride, NaCl, is the solute. So to find the number of moles of solute, we take 15 grams and we multiply by 1 mole of sodium chloride over its molar mass, 58.44 grams, and we get 0.2567 moles of sodium chloride. That's moles of solute. That's the top part of my fraction. Okay? 750.0 milliliters is the volume of my solution. Now, the nice thing about molarity is, for the most part, we don't have to worry about changing the volume of water when we add a solute. Solutes dissolve into tiny, tiny little particles that actually fit into the spaces between water molecules, and so you're not going to alter your volume of water by adding a solute to it. Now, if you add a whole lot, you might change it a little bit, but we're not going to really be working with solutions like that. Okay? But molarity has to be calculated with liters of solution. So 750 milliliters is equal to 0.7500 liters. Notice I keep all of the significant figures when I make that conversion. Just move the decimal point 3 places to the left. Okay, so molarity is the number of moles of solute, 0.2567, divided by the number of liters of solution, 0.7500. 4 sig figs in each of those, so my answer should have 4 sig figs, 0.3423 moles per liter, or just 0.3423 m. That's how you calculate molarity. It's very simple. Now we can use molarity as a conversion to find, for example, how many moles of solute are involved in a certain amount of solution, or how many grams of solute are in that particular volume of solution. Okay? There's two sort of magic formulas that I call them. The first is liters times moles over liters equals moles of solute. So liters is the volume. Moles over liters is the molarity. So volume times molarity is equal to moles of solute, because liters will cancel. You'll just be left with moles. The other one is, if I want the mass of solute, it's going to be volume, liters, times molarity, moles over liters, times molar mass of the solute, grams over moles. And so you'll see liters will cancel and moles will cancel, and I'll be left with grams of solute. So these are two very, very useful versions of the same formula that we use all the time. Volume times molarity gives you the moles of solute. Volume times molarity times molar mass gives you the mass of solute. Remember them. We're going to use them a lot. Here's an example. What mass of potassium hydroxide is needed if I want to make 255.0 milliliters of a 0.125 molar solution? So let's say I'm doing a calculation, or I'm doing an experiment, and the experiment calls for 255 milliliters of potassium hydroxide whose concentration is 0.125. I need to make this solution. I don't just have a bottle of this hanging around. I do have a bottle of solid potassium hydroxide, and I have water at my disposal, so I'm going to make this solution. I'm going to measure out 255.0 milliliters of water, and now I need to know how much potassium hydroxide do I have to dissolve in there to get a solution whose concentration is 0.125 molar? So I'm looking for the mass of solute. All right, mass of solute is volume times molarity times molar mass. The volume was 255.0 milliliters, so I have to convert that to liters, 0.2550 liters. The concentration I'm trying to make is 0.125 moles per liter. And the mass of potassium hydroxide is 56.11 grams per mole. That's the molar mass. Liters cancel, moles cancel. I'm left with grams. I have 4 significant figures in my volume. That's the one that's the one that I'm going to use for sig figs. So 1.789 grams of KOH is needed. So I go and measure out 1.789 grams, and I dissolve it into my 255 milliliters of water, and I now have a solution that is 0.125 molar.